Hello, super nerds, acoustic associates, to whom it may concern. Okay, super nerds. Recently, TwoSet went around their apartment looking for all the things that have various pitches. And I wanted to talk about the physics of that because that interests me. Interested persons. Maybe that works. Anyhow, so I'm going to hit this thing, and I'm going to tell you what happens when I hit this thing. So, ooh. Okay, so when I hit it, I'm exciting vibrations within it, right? That's what we call it. It's excitement. So I thwack it, and it starts waves that are traveling through the object, vibrational waves, right? And those in turn, when it's vibrating, they push the air around it, and that's why you eventually hear a sound, right? The vibrations create sound waves in the air that eventually reach your ears, or well, my ears. They're reaching your ears through a much more complicated process. They reach my ears and I can hear it, right? Now, some of those waves, when they hit the edges, are going to bounce back in particular ways, right? And depending on the shape of this thing, some of those waves are going to create more movement, vibrational movement than other waves, right? And that depends on three things. One, the shape. Two, how stiff this thing is, right? How easily it bends. And how much it, basically how much it wants to go back to its original shape. Its inertial mass, right? Has to do with its mass. So when I hit it, depending on those things, it might produce certain frequencies of sound, and therefore we may hear that as pitch, right? Now with this thing, I wouldn't even call this a pitched sound. It's a brief sound that doesn't have a real definitive relationship of the frequencies that we would perceive easily as a particular pitch. So when I hear it, I hear da 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 da, and you might hear something slightly different. And if I tried to just hit this thing and have a tuner decide what the pitch was, the tuner's going to be confused. It's going to give that little noisy, it's going to say noisy, 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 and maybe flip around a bit. It's probably not going to do a very good job of deciding through its algorithm or what have you, what the pitch is. However, I have this thing, and I have this thing. And even though the pitch might be ambiguous, you know already, is the pitch going to be lower or higher when I hit this thing? It's made out of very similar material, right? So it's going to have the same type of stiffness, and a certain area of this board is going to have the same mass as the same area of this board, right? And so what you really want to look at is the shape. So what do you think it's going to be? You know it's going to be higher, right? So let's see. So listen to this. Get that in your head. Pound it in your head. Now let's go to this one. See if we're right. Na, 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 of the frequencies that are being produced in the object that are moving the sound that we hear. The wavelengths are shorter. And when the wavelengths are shorter, the frequencies are higher. So that's why this is higher pitch. Bottles. So apparently Brett cheated, and by cheating we mean he was ingenious. Now we have to think about what's actually vibrating that's causing the sound, and it's the glass itself. So here we have more water, here we have less water, right? Here we have more mass than we have here, right? The bottle itself has a similar shape, but here we have more mass. That the bottle, when it deforms and it moves in order to push the air, it has to push more mass than here. Now you might be saying, wait a second, isn't it the other way around? I have more water in this. I have more water in this one, and I have less water in this one. So shouldn't this have the lower pitch than this? Well, what you're thinking of is when we blow over the top of it. And the air column is the thing that's vibrating. So it's the air column inside. So here, the air column is shorter than the air column here. So you have a longer wavelength, you have a lower frequency. So let me show you that. So here, more water. Think of that. And here I have just a tiny bit less water. But notice, even though it's a tiny bit less water, you can hear the difference in the pitch easily, right? When the air column vibrates and it resonates, it creates a very easily discernible pitch, because the frequencies that are created from that vibration have a particular relationship which our ears are attuned to. We can tell the pitch really easily. All right, so here. And now the one with a lot less water in it, right, is much lower, right? Because the wavelengths of the sounds that are being created are lower because of the shape of the vibrating column of air, right? And so since the wavelengths are longer, the frequencies are lower. Right? Pots and pans are fun. Pots and pans are fun because they act very similarly to bells and cymbals and things like that. And when you get into bells, many times you have fights between people as to what the pitch is, because that easily recognizable relationship that you get from this, not quite there with bells and cymbals generally, but there are more definitive relations. They last longer. They have more, there's the frequency content is there. It's just not related so perfectly, right? When I hit the boards, the frequency content is barely there, right? We hear because our ears are really sensitive to frequency, but it's generally, considered unpitched. But when you have bells, then things get kind of fun. Bowls, notice, made out of similar material, right? They have very similar shape. One's just bigger than the other. So take a big guess as to which one is going to have a lower pitch. Big, huge guess. What do you think? Okay, let's try it. Try to hold it by the lip. That's that's what I hear. Da, da, da. Okay, at least that's what I hear. So one thing that was really cool that happened during that video is, so they have a bowl kind of similar to this, some sort of pot, and they hit it, and then they're like, there's more than one pitch in there. And the reason that happens is because your brain is looking for that relationship that tells you that it's a particular pitch. Well, the frequencies aren't actually lined up perfectly, so it's searching for it. So it's kind of searching for this thing that's kind of ambiguous. So you get this whole, you know, is it a lady or is it a duck type of thing? And then your brain goes, no, maybe there's a lady and a duck. Because it's trying to think, it's kind of doing that sort of approximo thing, right? It's not definitely a lady, it's not definitely a duck, it's a lady duck, or maybe it's a duck lady, or maybe it's a duck and a lady. Let's see. And then what was really cool to me, because I'm a super nerd, is that when they hit it, and then they said it changed pitch in time. Right? It changed pitch and time. Well, some of the vibrations, right, are going to die out quicker than other vibrations, right? So then all of a sudden you're looking at the lady duck, right? And then the duck parts start just kind of fading away and you have the lady left, right? So that's what's kind of happening there, because they don't hit it again. They don't hit it somewhere different or anything like that. They just hit it and they listen, and it changed pitch in time. If you hit it slightly different place, you're also going to sometimes excite those different frequencies with different strengths. We already kind of know this intuitively. We bow near the bridge, it sounds different. It has the same pitch, but it sounds different than if we say bow in the center of the string, right? And so with bells, though, since not every frequency that's produced, frequency of sound that's produced by the vibration has that same relationship. If we're making some stronger than others, we can change the perceived pitch by where we hit it. Fun stuff. So I hope you enjoyed this video. If you like this sort of thing, please let me know. So I know if I should make more of these things, or if I should make more in-depth videos about acoustics for musicians. So thanks so much. Have a great day, and solidarity.